Dear friends, as you may know, Maths Aspirants is a collective of mathematics students, research scholars, postdoc fellows, and faculty members across India and abroad, started by myself in 2017. We used to organize several online programs to help the students who prepare for higher mathematics and PhD, PG entrances, and other exams like CSER, NET, GATE, NBS, and extra. So, as a part of the online problem solving session series, we today blessed to have Mr. Sourish Goswami. He is currently a junior research fellow at ISI Kolkata. Mr. Sourish did his M-Math from ISI Kolkata and qualified JRF and now doing PhD as a JRF at ISI Kolkata. So today's problem solving session is mainly on linear algebra. As all of you know, linear algebra is one of the crucial subject in any of this type of competitive examinations. So I am sure that today's session will be really beneficial for all of you. And I would like to express my gratitude to Mr. Sourish for being with Maths Aspirants. I welcome everyone to this program. Welcome, Sourish.
I'm sorry, can you just repeat the last part? No, there was a big
Yeah.
network issue.
I just welcomed you. You can start now.
Okay, so hello everybody, and I'm sorry for the network issues. So the thing is, I would be presenting some problems mainly from some of them would be quite basic. I would at the end of the session, I would give some problems to you guys to think about, and I've mainly created some problems that I basically want to discuss with you. So things they are mainly from the TIFR entrance exams, the GS1, the graduate school exam GS1 that is. Am I audible?
Yes.
Yeah. Oh, yeah. So, I would request you guys. So, when I answer, please try to interact by raising your hand. I will pick someone from you, and we can have a discussion. So, sir, I'm starting. Okay.
Yeah, sure.
So, the first problem. So, I will give you the background of every problem, but I just want you to assume that you know what vector spaces are, what fields are. So, let me start by a very simple problem. That it's not a problem; it's just a thinking. So a vector space over a field is an abelian group with an action of the field on it, right? Is an abelian group. Uh,
Sourish, are
uh,
you sharing the screen now?
can you just give me 1 second? I think I have a network problem. Just 1 second, please.
Okay.
Okay. If so, it's a map
Yeah.
from S cross B to V.
Yes.
So the map, as we know, just let me recall if there is some person who has not seen it for long ago. So the properties are just recall that 1 dot V must go to V, and it's kind of distributive over this. So this is equal to AV plus BV. So actually we can do this V plus W, and this distributes over it. What are we going to say? That AV plus AW plus, it's abelian, so the order doesn't matter. BV plus BW, the group is abelian, and it's associative of this sort, that is A, B of V. So this is the element of the field. We are acting it on V. It is same as A of BT. So vector space is nothing but an abelian group with a nice action of a field on it. If we ask this question conversely, this is the first basic question of today, which I asked to you guys. Let G be any abelian group. Abelian group, and F be any field. And F be any field. So can so in order to make a vector space, you need an action. So a map from F cross V to V that satisfies these properties. So given any abelian group G and any field F, can you make F comma G into a vector space with some action? That is my first question of today. So I hope the question is clear. The question is given any group abelian group G, any if V is there is some dot, this dot operation, A dot V, this you need to define. There is the multiplication by a scalar which you need to define so that all these properties holds. Can you make any abelian group given a field into a vector space? So kindly if you so let me give you a minute of time. So as I want the session to be interactive, so just raise your hand on the Google Meet if you can think of a counter example, or you probably want to uh, discuss some counter example which you have in mind. It's okay, errors are fine. So I'm just trying to share that particular thing so I can see if anybody's hand is raised. So okay, one person has this hand. Just let me wait for 1 minute, then I will ask you if any other people's person will hand. Just for a few seconds. Okay. So Shruti, uh, can you please open your mic and tell what what do you think would be?
So like it is not possible because if I consider field as my R and like
Okay.
my abelian group is my Z under like plus like addition. So here
So you are saying
like
integers under addition, G.
yes, yeah.
Okay. So let write. Let's just go slow. So F is R and G is Z. Yeah.
G Z.
So
So like when you take the element from R like which is not an integer, like you take it like it will not belong to Z. Like for example, anything like 1/2 into 3,
okay, let's take
like
one
you
by
can't,
two.
and 3 from
Okay.
Z, so 3 but does not belong to Z.
Okay. Let's take three. So uh, like uh, so what is the reason why this there is no action like this?
Like the third
So you are
property is not satisfied, sir. Like ABB is equal to A of BB. Like that will not get satisfied.
A. So just what you are saying? A B V is not equal to. So first of all, you have to define a map first. So what I mean to say, you have to define this first. So what is your definition of this action? So how we are you? So what I mean to say is that so you have to given a real number a and an integer n. You have to say what a dot n is, and it must be an integer. In order to so uh, in order you are trying to say that it's not always possible. So you have to like any of these axioms, you have to contradict. So from these properties that I mentioned. So you are saying that your intuition is right. You are saying that 1/2.3, the third axiom is may not handle, may not work, but you have not
Yes.
yet defined what 1/2.3 is actually.
Oh, okay, sir. Like our
So
normal multiplication, like take element from field like A into V, like AB. That like our
okay, so you
multiplication.
are saying take a real number and natural number, a real number and integer, and send it to an, right? So
Yes.
just the multiplication of a real number. So this is not a map onto integers, right? So you are so what I mean
Yes,
to
sir.
say
Yes, sir.
that
I get.
do you get it? You have to show no such action exists like this.
Mhm.
Was the point clear? Okay, that's good. I
Yes,
just
sir. Yes.
want conversation. So okay. So in another person raised their hand, I guess. So uh, if anybody has some new idea, then they raise their hand. So I don't have many problems in hand, but I've so the discussion is important. So okay. So, does anybody else have an idea? So, so the answer is no. It's not always possible. So, can anybody think? So if anybody raises their hand, has anybody raised their hand? Okay. So let me give. Okay, somebody has raised their hand, right? Yeah, Onik. Okay, yeah. Please say.
Hello, sir.
Yeah.
Yes, sir. The problem I'm facing is that will we ever have any kind of natural map from F cross G to G? Means I'm not being
I'm
able to
not asking
construct
for.
something.
Okay, you don't need a natural net. Like my question is, I understand what you are trying to think, but does such a map always exist given a group and a field? Like if you can just give me any map that works.
Yes, of
So
course uh, we can consider a map where A cross V means A comma V always goes to V. This is a map, right? Means we
you
can
are
construct
saying
some map,
me
but
V goes to. Okay, so I get what you're saying. So every scalar multiplication is the identity map, right? So you're taking any scalar multiplication A dot V that goes right. On it, did I hear it correctly? Okay, you guys can hear me, right? Is he not answering? Like, is there is some issue with his net? Hello, can you hear me? Can somebody please answer if they can hear me?
So your
Yes,
voice
sir.
is actually breaking.
I am sorry. I'm really sorry. So there was today only there is a problem net outage. So is now okay?
Yes, sir.
Okay. So now then, my voice is coming across clear, right? One second. Yeah. Hello. Is so Oni? Can you please speak now? So okay. Just a minute. So now can everybody hear me? I guess now it won't be a problem.
Yeah, Sourish, you are audible, but your screen is not visible now.
Yeah. Okay. Okay. Now it won't be a problem. I'm sorry for the what happened. So there was a network error. Okay. So I guess I was talking to Onik. So Onik, you are saying that the map must be A dot V goes to V, right? This will be every action, right? Hello? Is the person who gave me this map in the meet?
Hello, sir. Yes, sir.
Yeah.
Actually, the battery went down and I got.
It's okay, it's okay, it's okay. So you are telling me that every scalar A dot V goes to V, right?
Yes, this might be a map.
So you have seen vector space, you have learned linear algebra, you have seen linear algebra before. So do you know that 0 dot V must always be 0?
Yes, yes.
Will 0 dot V work here?
No,
The map
no.
you gave. So you are
This will
getting
not
right
work.
that this map you are giving, it was a very good idea. Okay, this fails only here. So where does it exactly fail? So 1 dot V goes to V, this is a good idea. But thing is, if you take 1 plus 1 dot V, suppose something like this, then according to your definition, it must go to V. But by the
Yes, yes,
distributive
yes,
property,
right.
it must go to V plus V. So equal to V. So you are getting the problem, right? So by cancellation law, every V must be 0. So that was the problem
Yes.
with the definition. So okay, very good approaches. So can anybody else tell me? Anybody else have any idea? So just raise your hand because I need to move to other problems. This was the first one. So okay, let me give the next hint. So do you know what is the hand? Okay, no. So
Hello, sir.
yeah,
What if we send all A dot V to the identity of that group?
so you are meaning to say A dot V equal to 0.
Yes.
This is a good idea, but 1 dot V needs to go to V, right?
And what if we restrict that means the group only to its identity? Then everything will work, right?
I did not get what you were trying to say. 1 dot V to its identity means?
And see if G contains only E, but that is very
So you
very
are
specific case, right?
so are you saying that every element except identity maps it to 0, something like this?
No, I am telling that if the group contains only the identity element, then everything
So
works
that is a
fine.
0
If
group,
one,
right?
yes, right.
So you know that I gave a so let me give you an example. So let me ask you. So everybody knows the fields. This is a field. Does everybody know it? Z by 2Z. This is the. Uh, does everybody know this? This is a field. So in general, Z by MZ is a ring, and this is a field if and only if n is prime. So this is the first thing of group theory. So my first hint is show that if the field is Z by 2Z and the group is Z by 3Z, there is no action of the field on G so that it makes it into a F vector space. So it's difficult online, as mentioned before. So can I see just a raise of hands who have seen, who knows what Z by MZ is and some properties of it? Just raise your hands in the meet. So if you know what Z by MZ is. So only two people know what Z by MZ is. I hope not. I guess. Okay, so I hope other people also know. Okay, so this is just the beginning of group theory. So uh, okay, so what you need to show is that if f is z by 2z and g is z by 3z, then there is action, right? How will you show it? Well, one dot so uh, so just see this action. Take one from, so you have to be careful from where the elements you are taking. So 1 is the element of Z by 2Z. You're taking the field element. Let's call this 1F. Add your, if there was an action. What I mean to say that if there was an action of F on G such that it made it into an F vector space, F vector space, then 1F, that is the identity element of Z by 2Z, must send 1G. Now G is a group, there is no identity element here. 1G is the generator of the group Z by 2Z, but any non-zero element is a generator, but that's okay. Here 1G means the element 1 bar here. This must go to, if there was a group, if there was a field, if this was a vector space, if then 1 must go to 1G. But this map must be well defined, right? So 1F, so 1F is the element 1 bar in Z by 2Z. And 1 bar plus 1 bar plus 1 bar is equal to 1 bar here. That is 3 bar equal to 1 bar in Z by 2Z. So, since so there is a lot of abuse of notation here. So 1 bar dot 1 bar equal to 1 bar. This is an element of the field. This is an element of the group. This is an element of the group. We are assuming such a group acts such a, it is a F vector space. Then 3 bar dot 1 bar must also be equal to 1 bar. But 3 bar is nothing but 1 bar plus 1 bar plus 1 bar, which is equal to 1 bar. Equal to 1 bar. Now use the distributive law of the vector space axiom. This is equal to 1 bar plus 1 bar plus 1 bar, which is equal to 1 bar. Now everything is in the group. So this is equal to 3 bar. But in Z by 3Z, 3 bar is 0. So this is equal to 0. So the generator is equal to 0, which is a contradiction. So it is not always possible, given any field and any group, to form an given any field and any group, to make it into an F vector space if G is an abelian group. Okay. So the first question went. So maybe it was too simple for a few. So let's me go to a bit difficult question. This was a question of TIFR GS1. So I hope everybody knows what a minimal polynomial is. If not, let me define it. So Shruti, you raised your hand. Do you want to say something right now? Or was it because the last time when I asked to raise the hand?
No, sir, it was the last time that you.
Okay. So can somebody tell me what a minimal polynomial of a... So everybody knows what if V is a vector space over some field, T is a linear map from V to B. A linear map, I hope everybody knows. So just let me know if you don't know what a linear map is. So does everybody know what a minimal polynomial of T is? Can I get, can anybody raise their hand and tell me? Raise your hand if you know, I will ask you. Minimal polynomial of T is. So somebody kindly, okay. So those who know what a minimal polynomial of a linear operator is, kindly raise your hand. Okay. Nikki has raised her hand. So I guess. So can you please tell me, Nikki, that what is the definition of a minimal polynomial? Nikki, right? I'm saying it correctly, I guess. Yeah, Nikki, please unmute yourself and tell me what a minimal polynomial is. It's okay. It's okay if you are wrong or are not completely confident. Just try. This is an introductory problem, Shishok. Uh, okay, I guess Nikki is having some problem. Then, Kaushik, can you please unmute yourself and say what a minimal polynomial of T is?
Yes, it is a polynomial, a monic polynomial of least degree which annihilates Lie.
Okay. So, okay, don't unmute yourself. So, I will try. I will the problem I give. I will ask you only. So, you are saying me if T is a linear operator from V to V, it is a monic polynomial. So, can you say me monic polynomial where? So, you have to give me the coefficients, right? You have to in complicated terms. You have to give me a polynomial ring of which, or can you say me coefficients are from where of this polynomial?
From the field. From the field.
of which V is a vector space. So it's a monic polynomial of least degree. So is this unique? That what I mean is that can there be F and G? You said annihilates, right? Which annihilates T, right?
Yes.
So you mean to say F of T is also a linear operator, and this linear operator is zero. That evaluated at every V, F T of V is equal to zero, right?
Yes, sir.
Okay. So is this monic polynomial unique? I'm just asking you. Can there be two F and G monic polynomials which are as polynomials are different, but they are both monic, they are of the same degree, which is the lowest degree possible, and both annihilate T.
No, sir.
So this is unique, right? So there is exactly one monic polynomial of least degree uh, which annihilates T, right?
Yes, sir.
So there might be a confusion. Somebody may say, I'm already saying that it is of least degree. So their uniqueness is already mentioned, but that's not necessarily true. There can be two F and G which are of same degrees, and both of them annihilate T. Okay, so do you know why such an unique monic polynomial of least degree exists? Let me ask you, Kaushik. Yes, sir.
I'm not sure, but I think the proof involves this divisibility thing.
Okay, so do you know what a PID is?
What, sir?
A principal ideal domain is?
Oh, yes, yes.
Okay, so every okay, so I hope everybody is actually familiar with what rings are. So we take T and we are taking the polynomial ring Fx. Given any polynomial f of T is a linear operator. So I have to make sense of what I am saying. Linear operator. So f of uh, so suppose, let me give you an example. If f is equal to x, then f of t is just the linear operator t. If f is equal to x plus 1, 2x plus 1 over r, suppose, then f of t is equal to this linear operator 2t plus identity. If f is equal to x square, then ft is equal to t square. So we are taking something called an ideal S M, which are all those polynomials f belongs to fx, such that ft equal to 0. So Kaushik, you know these are called analytic polynomials, right?
Yes, sir.
Okay, so this is an ideal. Okay, if not, so this will be an ideal. Okay, so you know what an ideal is, right?
Yes, sir. Yes, sir.
Is an ideal. Okay, so since this is a principal ideal domain, every ideal must have a unique generator. Not a unique generator, must have a single generator, right?
Yes, sir.
So if there is a single generator, suppose F, and the leading coefficient is not monic, but since it is from a field, you can multiply it by its inverse and make it to be monic. It is still in that ideal, right? Did it make sense? So if F is, so suppose F is this generator of this Sm, then we are so this is actually what you said by divisibility algorithm. This is the least degree polynomial that this is the least degree polynomial in this SN. So in if fx is any polynomial ring, take any ideal, so the least degree polynomial in that ideal is a generated of it. Okay, that is absolutely correct. So you are taking any generated f, but it may not be monic, right? This f may not be monic. Its leading coefficient may is an element of maybe an element of the field. Are you getting what I'm saying, Kaushik?
Sir, I'm actually processing what you just said.
Okay,
Can you
okay,
please
okay. So
repeat it?
surely. So A sign is an ideal. Take it for me. You can check it later. So since if it's the principal ideal domain, A sign must have a single generator, right?
Yes, sir.
So the single generator must be a polynomial, right?
Yeah, yes.
The polynomial may not be monic, right?
Yes, yes.
But its leading coefficient is a unit, right, in the field.
Yes, yes.
So you can multiply it by its inverse and make it monic, and it will still be in SN, right?
Yes, yes.
This is actually the minimal polynomial. Okay. So F is a minimal polynomial. So this, so and if so, first, so there is a monic generator of this that we call mean poly of T. And if there is if there are two f and g, so that f is not equal to g and f and g are both monic, you can just take f minus g. Since Sn is an ideal, f minus g is still here, but the degree reduces. So that is a contradiction. So this is actually necessarily what you said was the construction of a minimal polynomial of T. But there is one problem. Uh, how like are you sure that this won't be the zero ideal? So the minimal polynomial must be a non-zero polynomial, right?
Yes, sir.
But why is it true that SN is not the zero ideal? Why must a analytic polynomial exist, non-zero analytic polynomial? Are you getting the question? What
Because
I'm trying? Yeah, say.
yes, because for every linear operator, the characteristic polynomial will always annihilate.
Okay, that's very strong. So characteristic polynomial annihilates, that is Cayley-Hamilton theorem necessarily. So that is way overkill, and it some kind of needs this fact that this is non-zero. So can you give a simpler reason? So okay, uh, okay. I guess Nithi, I will ask you the next question if you were trying to speak. So okay, no problem. So can you hear me properly? There is no net problem, right, Nithi? So I guess you raised the hand beforehand. And okay, so okay, Kaushik. So this reason is, do you know what LV comma V is? Kaushik, I am asking you.
Collection of all linear maps from V to V.
Okay, if V is of dimension one, if is dimension n, do you know this is also a vector space, right? Do you know what the dimension of this vector space is?
Yes, n square.
Very good. So okay. One second. So if I'm very sorry. Yeah, so yeah, T is an element here, then T square. So I T square T to the power n square. How many elements are here? These are all in N V comma V. Can you tell me how many elements I wrote?
N square plus 1.
Exactly. So they can't be linearly independent, right?
No, sir.
So there must be some relation CIT in STIC TI, where I runs from 0 to n square. So that this is equal to 0, right? There
Yes.
must be some non-zero CI. So you're actually getting, so this exactly this polynomial is an analytic polynomial. So there a non-zero analytic polynomial exists, right? You proved exactly this, right?
Okay, okay, sir.
Okay, so you get it. So, but you used a crucial thing. You used that V is finite dimensional. Okay, this was the
Yes, sir.
only fact you use. So this is the
Yes.
first problem of the day. That is give an example of a linear operator. So thing is, if an annihilating polynomial exists, then a minimal polynomial will exist. That is true. But for infinite dimensional vector space, no non-zero annihilating polynomial will exist. So give an example of an annihilating polynomial. So give an example of a linear operator. This is where people linear map actually linear to that. Because most of you, I think, have seen only finite dimensional vector space. Those who are in the UG at least. Give example of a linear map P from V to V, where V is infinite dimensional, where dimension if V is infinity. Because Cauchy just now proved that there will be always be a minimal polynomial equal to infinity, has no non-zero annihilating polynomial. Okay, very good, Kaushik. You actually exactly un- understood the basics quite right. Okay, so I would prefer the method, and I would ask somebody else. I would give them hints, and I would so I would call upon Kaushik. But does anybody else want to try this problem? Just raise your hand. So this is quite. So I will give you hints, and those who know BSc level linear algebra somewhat, those who know this solution exactly. This is a TFR question. This is mainly if I am asking BSc students. So master student may know this answer. So those who don't know this solution but are willing to try and know what and have seen what minimal polynomials are before and know what a shift operator is. So okay. So let me frame my question better in a better way. So has anyone seen does anyone know what a direct sum of vector spaces is? Please raise your hand if you know what a direct sum of vector spaces is. So this is a big problem here. So Shruti, if you okay, your hand is still raised, so it might cause a little confusion. So if you are so if it is from okay, thanks. So please raise your hand. No matter PGA, if you know what a direct sum of vector spaces is. Okay, Kushing knows, but does somebody else? Okay, let's try someone else now. This time, Orpo. Okay, so Orpo, kindly unmute yourself. So can you tell me what a direct sum of vector spaces is?
Yeah, yes, direct sum of vector spaces you can think of like a similar to Cartesian product. We can take like the elements in as a pair.
So just tell me what uh, direct sum of R, uh, uh, countable direct sum of R is. Can you tell me what is this is? So n greater than equal to 0. Can you define? Tell me. So it is not the product. So this is not Cartesian product of R. Direct sum is not Cartesian product of R. So
Yes, it is. Hello, hello. Am I
yeah, yeah,
audible?
yeah.
Yes, it is. I mean, you can express the elements as the sum of the vector spaces. I mean, as suppose some element is a product, some element is from the direct sum, so you can express it as a sum of the individual elements from
Okay, I
the
get what
vector
you are
spaces.
saying, but that is uh, so you are saying that it can be written as finite sum of elements of each of these are uniquely
Mm,
what you are saying. That is
yes, yes,
right,
yes.
but that is not that that follows from the definition. So all these are later stuff. The definition is not this. So okay, maybe somebody else. Okay, who knows
Sir,
what a yeah?
just
Can you
two
please raise
disjoint
your
sub.
hand? Can you just raise your
Yes,
hand
sir.
first? Okay, I will ask you only, but kindly raise your hand next time. It becomes a big problem. Yeah, Vaibhav, say.
Sir, if two disjoint subspace of a vector space form if summation of two disjoint subspace form the whole vector space, then that can be a direct sum of a vector
So
space.
you are saying, first of all, I did not say subspace anywhere, but that's okay. That's not a problem. So you are saying a V a vector space and W1 and W2 are two subspaces. So you are saying if W1 plus W2 equal to V, then uh, this is direct sum.
Yes, sir.
No, that is not true actually. So what you are saying that any element can be written as sum, but this expression won't be unique. So what another
Yes,
condition is W1 intersection W2 must be the zeros. So this is another
yes,
condition,
that
but
is disjoint subspaces.
not disjoint, but yeah, trivial intersection. Yes. So okay. So actually, what I am asking the question is if Vi are a vector spaces, an arbitrary family of F vector spaces. Can anyone tell me what this means? There is no subspace or something. Can anyone tell me what this is? So this is from some index. So okay, let's countable is a countable family of vector spaces. Let's make this easy. Can anybody tell me what this is? So I guess Kaushik raised your hand, but can somebody else? Okay, I will go to you. If okay, Onik raised his hand. Okay, 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 Onik, you can unmute yourself and tell me the definition.
Can you repeat
Uh,
the question, sir?
oh, okay, okay. So, okay. So the question is, if Vn are F vector spaces over a fixed field F, there are countable family of vector spaces Vn. Can you tell me what direct sum of Vn is?
Mm. That must be uh, the span of all of
No, no.
those,
You have to
and
define
the
me.
Vn.
You have to tell what the set is first, right? In order to make it a vector, like before vector space, you have to say what are the elements of this set, right?
Right, right, right. Oh,
So what?
well, if this set contains, yes, I may define it like this, that this set contains all the finite linear combinations of
Okay.
elements from means
Okay. So I
finite
okay.
linear
So
combination.
that's so these are actually you are correct, but you guys are like what I was saying first saying the theorem and then the definition. So this is it's what you said is correct, but in some sense, but not continually. So these are all infinite countable tuples of this form. So these are all sequences such that AI belongs to VI and there exists N such that n equal to 0 for all n greater than equal to n. What I mean to say is that if I take R, so R is an R vector space, is a R vector space. If I take direct sum R, so the index matters, direct sum R, n greater than 0, 1, comma 0, comma 0, everything 0 is an element, but 1, comma 1, comma 1, everything 1 is not an element of this. So in this case, these are all sequences which are 0 after one point. What sequences that you have read in the analysis? This forms a vector space. So Onik, was it
Yes,
clear? The definition?
so we are taking into account all linear combinations, like finite linear combinations, right?
Yeah,
Just to avoid
yeah,
that problem of convergence.
yeah, you are taking finite linear combination. But thing is, there is some sort of uniqueness also there. Okay, so you have to then say when two linear combinations are same, when two are different. Okay, so
Okay, okay, okay. So we shift
that
to the
condition.
definition, means we shift to the viewpoint of that coordinates, right?
That's why
Means
you shift to the
we are
viewpoint of coordinates. Yes.
okay,
Yeah.
right, right.
So okay. So essentially, if someone has seen the that any finite dimensional vector space can be written as finite direct product of fields, where this finite direct product is a number of dimension. So what I mean to say, if V is of dimension 2 over F, then V is isomorphic to F cross F. But over infinite dimensional case, this is also true. So they are direct sum comes, not product. So in for finite case, product and direct sum are everything is same. Okay. So okay, so I want somebody else to help me solve this problem. So uh, okay, so those who have seen the definition that I wrote before, please raise your hand. Kaushik, you can raise your hand. I guess you have seen this before. So if anybody else who has seen the definition I wrote before, please raise your hand. And I will. So where does this vanish? Okay, yeah. So if anybody has seen this definition before, the exact definition I wrote right now, can you please raise your hand? This definition. So this definition that I wrote right now. And I will take your help to solve this problem. So don't worry, it's so has anybody raised his hand? Okay, can't see. Okay, Shruti raised her hand. Okay, Shruti, please unmute your mic. Let's solve.
Yes, sir.
Just try to solve this. Okay, so you've seen this definition before, right?
Yes, sir. Yes, sir.
Okay. So can you give me an operator? So do you know what a shift up? So direct sum are. Let's take countable direct sum. Let's keep everything easy. So direct sum are n greater than equal to. Do you know what a right shift operator is?
So
So
like we are like moving the like
coordinates.
like we are
Yeah.
changing our coordinates like towards our right.
Okay, so you mean to say
delete-
so first thing is that I want to say the intuition is perfect, but you all have to be specific. So this is an element here. This goes to 0, comma a1, comma a2, like this. This is what you mean, right?
Yes, sir.
So
Yes,
what you mean is that the first coordinate will be 0 and ai will go to ai plus 1. So
yes, sir.
just tell me if I say 1, 0, 0, all these elements, where must this go to under this
0,
T
1,
map?
0, 0.
Right. So let's call ei to be that coordinate where every coordinate is 0 except the ith coordinate. The ith coordinate is 1. So okay, so let's keep this away for now. Can you tell me what is the dimension of this vector space is, Shruti? This direct sum in, so it is infinite dimensional, of course. Can you tell me a basis of this vector space?
So our standard EIs.
Okay, this EI that I wrote, right? So
Yes.
so you know what a direct product of R is, right?
The some
Just the
summation.
Cartesian product, right?
Yeah.
So what is the so were you saying something?
No, sir.
Okay. So the direct sum of R and direct product of R, what is the difference? Can you tell me? Like direct product of R, something is allowed. What is in so direct sum of countable direct sum of R are nothing but sequences, right? And countable
Yes.
direct product of R are also sequences, but something is not allowed in direct sum of R. That is in the definition. Can you tell me what it is? So like, can this element, every coordinate 1, be in direct sum R? Every coordinate is 1. Can this be in direct sum of R?
No, sir.
So after some point, everything must be 0, right?
Should be 0. Yes, sir.
So on direct product of R, this is allowed, right?
Yes, sir. Yes, yes.
So this is the basis of this EIs are basis of direct sum of R, not direct product of R. Okay. So
Okay.
suppose you are giving me any element C1, C2, Cn, then everything is 0. You can write everything is after that everything is 0. You can say this vector V is equal to summation Ci Ei, where I is a sum from 1 to n, right?
Yes.
So you have explicitly told me a basis, and this is a countable basis, Ei. So you have okay. I for I'm sorry, this is yeah. So I belongs to natural number. You told me that this is a basis, right? Okay, so now let's go to the problem. So we have a shift operator from 𝕸𝕬𝕐 R. So you followed the previous problem, right, of the analytic polynomial one, Shruti?
Yes, sir.
You
Can you
followed the
repeat?
previous problem, right?
Yes, sir.
That any linear operator in a finite dimensional vector space has a non-zero analytic polynomial, right?
Yes, sir.
And you gave me a map right now on an infinite dimensional vector space. That is the shift operator, right?
Zero. Yes. Zero.
So the thing is, I will claim that this has no non-zero analytic polynomial. Okay.
Okay, sir.
So what we need to show? So we need to show if f. So just tell me if what I'm saying is correct, right? If T has no non-zero analytic polynomial, does it imply that for every non-zero real polynomial, since the underlying field is a non-zero polynomial, if f of t is a linear operator, right?
Yes.
So if it is not an analytic polynomial, there must be some v in this vector space, some v belonging to this vector space. So the f t of v must not be equal to 0.
Not equal to 0. Yes, sir.
Absolutely. So tell me give me an expression of f. So we have to prove this, right? If we can prove for every non-zero polynomial f, ft is a linear operator, and we can show some v so that if v is not equal to 0, then we are done, right?
Yes, sir.
Okay, so
By contradiction.
no, this is actually constructive proof. This is, so
Okay.
you are showing that every non-zero polynomial is not an analytic polynomial. Okay, so this is not a contradiction proof. So okay, so like every okay, so that's right. So give me an expression of f. Could you give me an expression of a polynomial? Like how
Like
does a
A
polynomial
naught,
look?
A naught plus
Yes,
A1x plus etc. An x power.
exactly. So a0 plus a1x plus dot dot an x to the power n, where an is non-zero, right?
Yes.
Others can be 0, but an is not equal to 0, right?
Yes.
So now we will come to the contradictions thing you were speaking about. So suppose f is an analytic polynomial. Okay, one second. So let's give suppose f is an analytic polynomial. So first let us try with some examples. F is an analytic polynomial. First take f equal to x. Just take one element. You remember what the element e1 is, right? That is the first coordinate is 1 and everything else is 0.
0. Yes, sir.
So can you tell when f is equal to x, what is ft of e1 is? Can you tell me what it would be?
It is only the first coordinate.
Shifts, right? So it is nothing but t of e1, right?
Yes, sir. First coordinate.
So this is just e2, right?
Yes, sir.
So can you tell me what if f is equal to x to the power n? Can you tell me what ft of e1 is then? So yeah, so to make things easier, okay. No, you're doing good. So can you tell me what? So this is nothing but t to the power n of I. So can you tell me what is this element?
Is
So
it
it
like
is
sir, En plus 1?
exactly. Very good. En plus 1, right? Okay. Then can you tell me if C is any non-zero, C is any real number? Can you tell me what Cx is? Now can you tell me what Ft E1 is?
It is C like C.
C n plus 1, right? So now can you tell me if f is of this general form? So okay, so so if so you have done the problem basically. So a0 a1x plus dot 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 a n x to the power. So if f was an annihilating polynomial, ft of e1 must be equal to 0, right?
Yes, sir.
So just another last thing. If f is a constant a0, any non-zero real number, so can you then tell me what ft of e1 is? So this corresponds to the identity map into a0. So just a0 of e1, right?
Yes, sir.
Okay. Now a0 of e1 is nothing but a0 comma 0 comma 0. Everything else is 0, right?
Yes, yes, sir.
This is nothing but everything else 0, but on the n plus 1 position there is c, right?
Yes, sir.
Then ft of, so we assume f, so we have used f many times. Let us assume g is an annihilating polynomial of this general form. And since g is not a zero polynomial, we assume that a is not equal to 0. Then gt of e1 must
Yes,
be
sir.
0 since g is an annihilating polynomial. But gt of e1, just tell me if I'm
Sir, you're not audible. Sir. Sir, I don't know if I am audible or not. Sir, am I audible or it's sir's network?
Hello, excuse me, Sourish, are you there? Yeah, I think some network issue from Sourish's side. Let's wait. Yeah. Sourish?
I'm sorry if there
Yeah,
was some
Sourish.
network loss today. So yeah, Shruti, can you hear me? Let's continue.
Yes, sir. Yes.
So, and this is, as you said, the n plus 1 position is an, comma 0, 0,
Sir,
right?
your screen is not visible, sir.
I'm sorry, I'm sorry. I don't have habit of online teaching actually, so sorry for that. This technicality is, but it's still good. No problem. Okay, so
Yes, sir.
a0 I of e1, this goes to this. A and tn of e1 goes to this, where the
Yes, sir.
n plus 1 position. This is the n plus 1 position, right?
Yes, sir.
So you are getting, you giving a sequence a0, a1, dot dot dot, an, comma, then everything else is 0, right?
Yes, sir.
You just that I is actually the digital of 0. But what is it? According to that, since D is not there, A is not 0, then this is not 0. Does it make sense? This GT1 is not a 0 element in the vector space, right?
Yes, sir.
Since if it was 0 element in the vector space, every coordinate must have been 0.
Yes, sir.
So this is a contradiction. So you showed that there can be no non-zero annihilating polynomial. So a minimal polynomial. Very good, very good. So this is done. This problem is done. Okay, so let's go to the last problem of today. And this problem, this is not exactly, this is a linear algebra problem combined with the norm problem. So can I get a, so raise up hand, somebody who knows a norm on a linear vector spaces? Can you, so this problem may be a little difficult for BSc students. So just raise your hands if you know what a norm on a, okay, Kaushik has. So anybody else? Shruti also has what a norm on a vector space is. Okay. So Onik also knows what a norm on a vector space is. Okay, just me wait. Anybody else? Like if you're not completely confident, that is also fine to raise your hand. So like I'm saying, if you are not completely confident, it is also fine. You don't need to be exactly confident. So I will help you out and we can discuss. So okay, so Shruti and Kaushik both have answered one problem. So Onik, okay, you can unmute. So can you tell me what a norm on a vector? So can you hear me? Is am I not audible? Like yeah, hello.
You're audible, sir.
I'm sorry. Just give me 1 minute. There is a severe network fluctuation going on where I am. Okay, so 1 second. 1 second. Yeah. Just allow me 1 second. Hello. Can you guys hear me now?
Yeah, yes, Sourish.
Okay, okay. So Onik, you raised your hand, right? Just a second, there is somebody. Hello. Yeah, Onik, you raised your hand, right? Is Onik there in the meet? Okay, I guess not. Okay, Onik is there in the. Oh, okay, okay, it's fine. Then let's ask from somebody else. Kaushik, are you there? You raised your hand, right?
Yes, sir.
So can you? Okay, so let's. So Shruti did a difficult problem actually. This is a TI problem. So this was in GS1 actually. So okay. So suppose, do you know if V is a vector space? If V is a vector space over real numbers, okay, just not go anywhere else. Do you know what is a finite dimensional vector space also? Do you know what a norm on this vector space is?
Yes, sir.
Yeah, please define. Just tell
So,
me what
so it is a map
uh,
from V to R,
it is the map from V to R.
such that norm. Suppose X is an element in V, then norm of X is greater than or equal to 0, and it is equal
Norm
to
of
0
X is greater than
when
equal if and 0 if and only if X equal to 0
X equal to 0,
and
and
norm of
norm of
Cx
alpha
is
X. Yes,
okay
yes,
alpha X mod
is
alpha
equal
X.
to yes. and
Okay.
the triangle inequality.
Triangle inequality. Can I ask you where you are UG2 or UG3 or PG?
No, I have actually completed my MSc.
Okay, 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 you have completed yours. Okay. Uh,
Hello, sir.
from
Am I audible?
Yeah, yeah, you are audible now. So, Kushik, let's give Onik a chance. You said
Yes,
it
sir.
correctly. Let's give Onik a chance. Okay,
Yes,
yeah,
sir. Sure.
Onik, you're audible now. So, okay. So, do you know this definition that he said?
Yes, yes, sir. Means it is
Okay,
definitely like a metric only.
okay. So, this induces a metric. So, there are open sets under this, right?
Yes, of course.
So, do you know on R? So, suppose there are two norms. There is one norm and there is another norm. Can you tell, is this a relation between this? So this norm induces a metric here. There are open sets due to that metric. This norm induces another metric here. There are open sets due to that metric. So do you know some relation between this?
Uh, uh, no, wait, but there is some kind of surprising relation I had heard before.
Okay, okay.
Means
Does anybody know
I
the
think
relation? Okay, okay.
So
That's fine.
the open sets, the collection of open sets are same.
Yeah, yeah.
yes,
So
the
the norms are
convergence
equivalent.
criterions. Yes,
No,
yes,
no.
yes. Both the
Actually,
norms are
so
equivalent, right?
no. What equivalent is means is that so this norm induces a metric, right?
Yes.
So there are open sets under this metric. This term into there are open sets on this metric. The open sets are exactly the same. Okay. The set of open sets is same in
Okay,
weight.
okay, okay.
So if any norm you take on R, just not an R, let V be any let V be any finite dimensional vector space over R, or complex also works. Then then so if there is a norm on V, then we call it as a non-linear space. It's a non-linear space. Then any two norms on V are equivalent. It does not matter what norm you are working with. Topologically, this is the tradition. Many people know that any two norms are same. Any two norms on V are equivalent. All right. So this is the result. This is the result. You are in bachelor's, right?
Yes, I'm in UG2.
Oh, okay, that's okay. So not expected that you not required. You know now. So okay. So do you know? So M and R. So
Yes,
as
the
sets,
set
this
of
is
all
exactly same as
n
R
cross
and
n
square, right?
matrices.
So as sets, these two are
Yes,
same.
yes,
So
yes.
do you know any norm here on MNR? So specific norm? I'm just asking. You don't need it.
No, I do not know. On MNR, I do not
Okay, there is something called a soup norm here. So okay, you do not know it. Okay. So MNR is Rn square. So Rn square has a metric on it, right? There is a metric on this Rn square. That is a Euclidean norm, right?
know.
The
Yes,
distance, the
right.
usual distance, So MNR also has a metric on it, right?
Yes, sure.
So do you know what projection matrices are? That is matrices so that A square equal to A. Okay.
Matrices corresponding to a projection operator. Yes, right, right, right.
Okay, okay. These are it. So my question is, this is the last question of today. Take all this A belongs to this. Question one. Is this set? So this is a subset of Rn square, right? Is this set closed?
Yes,
It means, right? In Rn square. So this is not Rn square, this is R4 actually. Is this set bounded? These are two questions that I'm asking. So I will ask the bounded one, and there is a third difficult question. Is the set connected? So connected one, I won't resolve today. So okay, so let's not go into that. So first of all, let me ask you, Anik, can you give me an example of a matrix? So identity matrix and zero matrix are here, right?
Yes.
Can you give me something other than an identity matrix and zero matrix that so that A square equal to A? Uh, Anik, have you seen what your second year? So maybe a bit early. So have you seen what a minimal polynomial is before?
No, no, no. Minimal polynomial
Okay,
I'm
okay,
not
that would
familiar.
be a bit difficult. So okay, so let's try someone else. I will give you some problems to think later. Okay, so
Okay, sure.
somebody. Okay, okay. So good attempt, very good attempt. No, no problem. Somebody else who wants to try this problem. So who has seen norm before? Can you? Okay, so anybody? Shall I pick at random from here from the meet? So okay, let's see. Okay. Yeah. Okay. eh, Is someone here in UG third year who has seen minimal polynomial of this before? Can you kindly raise your hand? Who has seen all this before? Anybody who has seen metric spaces before, can they raise their hand? Shruti, Kaushik, you guys can. I guess you guys have seen before. So, uh, I am audible, right? Everybody can hear me, right?
Yes, sir.
So, anybody who has, can, so this is the last question. So, anybody who has seen metric spaces before, can they raise their hand? Okay. Vinod. Okay, okay. So, Vinod, can you please unmute yourself? Yeah,
Sir, please
Vinodini.
once again repeat the question, sir.
Oh, so I am asking that you have seen what you know what metric spaces are, right?
Yes, sir.
Okay. So, so let's come to this question. So, you know, A square equal to A are matrices so that they square it itself. So, is identity matrix is in S? Uh, Vinodini, can you hear
Sir,
me?
yes, sir.
So, is identity matrix and zero matrix is in S?
Yeah, yes, sir.
So, can you give me any close to matrix except the identity matrix and the zero matrix which is in S?
Sir, example 0101.
0, 1, 0, 1. Are you saying this thing?
Yes, sir.
Yes, this is in S. Exactly. Can you? So if I do it by hand, then yes, this will be in S. But so just compute it. This will be actually 0, 1, 0, 1. So can you tell me what the matrix you just said? Can you tell me what is the? You know what minimal polynomial is, right? I actually defined what minimal polynomial, but that is not enough. So you know, can you tell me what the minimal polynomial of this matrix is? If you have seen minimal polynomial before, can you tell me what the
Minimal
characteristic poly? Yeah. Okay. So say what the minimal polynomial is.
minimal polynomial means polynomial of least degree which satisfies this condition. It's right.
Exactly, exactly. Monic polynomial DC. So can you tell me what the characteristic polynomial of this is?
Mm, Is it for this questions or
Just
general?
just this matrix. Can you tell me what the characteristic polynomial is?
Oh, 0, 1, 0.
So you know how to calculate characteristic polynomial?
Sir,
So
please
do you
repeat
know
again.
how? Yeah. So do you know how to compute a characteristic polynomial of a matrix? Like the method. It's okay if you can't do it now, but do you know in general the method?
If we general means we use that condition a lambda minus I, a
Yeah,
minus
yeah.
lambda
So
I equal to
what
0.
you do is that, yeah, exactly. So if this is a not equal
My,
to 0, so the equal to 0 is Kaylee Hamilton. So this is, so if A is a matrix, that is A minus xi.
yes, sir.
So this is uh, 0, 1, 0, 1 minus x,
X
determinant of this
0.
matrix, x 0, 0
Yes,
x.
yes, sir.
So this is, let's change the negative sign. It doesn't matter. Just tell me 0x. So this is 0, 1, x minus
Yes, sir.
1. So the determinant of this is x into x minus 1. So this is x
Yes, sir.
square minus x. Now, do you know what? So this is the characteristic polynomial. Do you know Kelly Hamilton?
Yes, sir.
So you
Any
know by Kelly Hamilton, uh, if A is any matrix, then
A
care
satisfy?
pol
Can,
A of
yes, sir.
so is equal to 0, right? That is what you
Yes, sir.
exactly said. Determinant of A minus xi, this polynomial is actually equal to 0, right?
Yes, sir.
Okay, so not 0. This doesn't make sense. So if the characteristic polynomial is f, then f of a is a 0 matrix. What I mean to
All,
say is that.
yes, sir. Yes, sir.
Yeah. So this is actually the minimal polynomial also. So since x square
Yes, sir.
minus x is the characteristic polynomial, that means a square minus a equal to 0.
Yes, sir.
So then a square equal to a.
Yeah.
So this is a projection matrix, right?
Yes,
So
sir.
you gave a very good example. Just to make things simpler, I am saying this like this, like giving the one above. So you gave me actually this example, right?
Yes, sir.
So,
Between,
okay, yeah, exactly. So now S is bounded. So we have to ask, so is this a projection matrix? I'm asking you this thing. Is this thing a projection matrix? In general, is this a projection matrix for any real number t?
it means that it satisfies this condition or not. We
Projection
check it out.
matrix
Huh?
means this square is equal to a
Oh,
itself.
okay, sir.
That is, this square is equal to 1t. I'm asking this. Did you get the question?
Yes, sir.
So you can calculate that this square will also be this, and actually this its characteristic polynomial is also x square minus x. Okay. So this is that you showed, Vinodini, you just showed that 1t 0 comma 0
Okay, sir.
or for all t belongs to R, all these matrices are in S, right?
Yes, sir.
So
For all t, it's true.
okay, can you tell me the Euclidean norm of all of this? So okay. Okay. So this corresponds to 1t 0 0 this vector, right? In some sense.
Yes, sir. Yes, sir.
So if t is arbitrarily large, then the norm of this is root over t square plus 1, right?
Yes, sir.
So there are vectors of arbitrary large norm inside S. So S cannot be bounded, right? If S was bounded, every vector must have norm less than some natural number, right?
Yes, sir. Yes, sir.
So this is not. So you just proved that this is unbounded.
Oh,
So okay, very good. You actually proved this. So the close thing is a bit difficult.
okay.
So not difficult. This was a question of TFR also GS1. So very good, Vinodini. You absolutely did it correct. So just
Thank you.
lastly, yeah. So uh, anybody? So this closed problem. This. So just let me give you a hint, and then I will end the meet. So first, you have to know what similar matrices are. That is, uh, A and B are said to be similar. Those who don't know, if and only if there is an invertible matrix P, so that A is equal to PB P inverse. This is an equivalence relation on the relation of matrices, and A and B are said to be similar if this holds. So if A square equal to A, we are 2 cross 2 matrix, and A is not equal to identity, not equal to 0, then A will be similar to the matrix. So this is the similarity relation. The exact almost similar. So the one Vinodin gave, that is also true. It will be similar to this. Vinodin is one also works absolutely. So she actually gave me the matrix which will be similar to. So if A is any matrix in S, then either A is identity, A is either 0, or A is similar to 1 0 0 0. Okay, so let me pick one. So Kruti, I guess you know what minimal polynomials are, right? You have seen it before. So I guess you raised the hand, so I'm asking you. Can you please unmute yourself? Uh, okay, so uh, okay, so someone else who has seen minimal polynomial. Okay, so Kaushik, can you hear me?
Yes, sir.
Okay, so you know that this y it is similar to 1 0 0 0, y similar to I, similar to equal to 0. So
Uh, yes.
okay, so what I'm asking is, can you tell me what are the possible traces of this matrix? If A square equal to A, what are the possible traces of this matrix? So
Oh,
underlying field is R.
okay. So the possible eigenvalues are 0 and 1. So trace
Okay,
will
okay.
be
So do you know that similar matrices have same trace? So this is everyone should know. This is a UG level stuff. Similar matrices have same trace, same determinant, same minimal polynomial, same characteristic polynomial. Okay.
yes, yes.
So if A, so tell me. So as I said, if A, so this is the hint. You guys have to work it out. So if A square equal to A is a 2 cross 2 matrix, A is either equal to I2. If A is equal to I2, then what is the trace? Can you tell?
2,
If A is equal to 0, the trace is 0.
0.
And if and last case trace is 1, right?
Yes.
So uh, okay. So can you tell me if this so this was all overkill. I was just trying to see. So can you tell me that is this set closed or not?
I'm not sure, sir. I think
Okay,
uh,
okay. Let's
actually
see
I've
here.
seen this type of problem before where this trace cuts the makes two. Oh no, I'm saying
Okay, okay,
something.
okay, okay. So actually, this trace problem was used removing the 0 and identity. Is this closed? That is a bit difficult question, but this is not very difficult. So let's see. Define a map from MNR to MNR. The map is every matrix goes to its square. Is this a continuous map? So this is not square of every element, right? This is matrix square. But is it a continuous map, Kaushik?
Yes,
Okay. So then A square minus A. This map is also a continuous map, right? A goes to A square minus A.
yes, yes.
So now can you tell me, will it be closed or not? M2R. So what is the definition of a continuous map between two matrix spaces? Kaushik, can you hear me? Do you know what the definition of a continuous map between two? So open
Yes.
set definition. Do you know?
Oh, inverse image of open set
Open
is
set is
open set.
open. If and only if.
Yes.
Can you formulate this in terms of closed sets?
Inverse image of closed sets is closed set.
Is zero matrix a closed set in M2R? The singleton zero. Is it a closed set
Singleton
in
zero.
M2R?
Yes, yes. Yes,
So
yes.
can you tell me what T inverse zero is under this map? Under this map, zero is zero matrix.
Yes, it is, I think, matrices which satisfy a square minus a equal to 0.
That is square equal to a, right?
Yes, yes.
So exactly this is. So you gave me a continuous map T whose S is inverse image of S. So since it is an inverse image of M2R, right? Is it fine, Kaushik? Did you get it?
Sir, your voice was breaking when you were speaking.
I'm very sorry. So T is a continuous map. You said zero is a closed set, and you said T inverse zero is the S, the first S that I gave earlier, right?
Yes, yes.
So does this establish that from your definition of continuity that inverse image of closed sets must be closed? Does it establish T inverse zero is S? That S is a closed set. Does it establish?
Yes, sir. Yes.
Yeah. So you showed that S is closed, but and Vinodini showed that S is unbounded. So it is not compact, but it is closed. My urge is to think similar problem like this. Like make polynomials of your choice. Okay. So take any polynomial. So define for any polynomial f, non-zero polynomial in M2R. Suppose take SF. Take all such A belongs to this. Is a fun exercise for all of you. M2R. You can make 2n. And you can check and see all such fa equal to 0. Check the topological properties of this. Check when SF is closed. Check when SF is bounded. Check when SF is connected. The connected thing is the most difficult. It's closed. Yeah. So, yeah. So this won't be connected most probably. Okay. So this is not connected. This is as far as I can see, this will have three connected components. So, okay, that's not a problem for you. But the thing is, this is a general strategy of checking whether subset is closed to try to find continuous maps and check under inverse images of this. Okay, so these were two TFR questions tweaked a bit, and the first was a general question. It was good. So yeah, so sir there. So sir, my thing is done for today. The time is also over. So I am ending
Okay.
sharing the screen. I am handing over to you. I'm sorry for the net problems.
Okay, it's okay. Thank you, Sourish, for this nice session. Dear participants, feel free to share your feedback. All of you are encouraged to share your feedback. Please unmute.
Yeah,
And
if you like something that would help you understand it better next time,
yeah,
or if you have any questions, please ask.
yeah.
Sir,
Yeah.
sir, I ask one doubt, sir.
Yeah, sure.
Sir, last you gave me exercise A belongs to M2 of R such that f of A equal to 0
Mhm.
to show that SF is connected.
SF is connected, yes.
right?
So I am asking when. So if is a random polynomial, SF is may not be always connected. Okay. So what
Yes,
I am
sir.
asking is take polynomials of your choice. So uh, so my question is this S I gave right now. Okay, that A square equal to A. Okay.
Okay, sir.
Check if this is connected or not. Okay, that was my exercise. Okay.
Okay. Okay, sir.
Yeah. Fine. Okay. So any other question
Mm.
or
Oh,
doubt?
first I will try it and next I approach you, sir.
Okay. Okay. Sure. Sure. Okay. So any other? If anybody else wants to share something.
And also, I really enjoyed this session, sir.
Thank you. Thank you. Thank you. It's been my pleasure.
Thank
Thank you.
Thank you,
Thank you, Vinod. Yeah. Any others? Any questions or any feedback? Any comments?
Sir, I have an doubt, sir.
Yeah,
Surely.
Sir, in the beginning of the session, you started with the one question, sir, like the group action, like F cross V to V. Can we relate this to? Can we relate the same thing for the module, sir? Module over.
Okay. So you are asking if R is any ring, and so actually, if R is any ring and G is any abelian group, must there be a module action, right?
Yes, sir.
So just think if R was a field, then any vector space action is a module action. So what I mean to say is that, so the question you are asking is if G is a group and R is any ring, will there be always be a module action, right?
Yes, sir. Yes.
Yeah. So thing is, we have already answered this question in a very, so thing is, the question you are asking is a very big, is a easier question than the one we answered. Because now you, so your question was, so what I'm trying to, so to make this sense, you asked a question in a bigger set, okay, and I have shown in a smaller set. You are asking a question over all rings that contain all fields, okay, and any field which acts, which has a module action on a group makes it is a vector space, okay. So fields don't have, so if F acts on V, A acts on a abelian group like a module, then G is already a vector space, okay.
Okay.
So answering this for fields is even stronger, okay.
Stronger than that. Okay. Sir.
Yeah, stronger than that, okay. Yeah, well, so
Yes, sir. Thank you, sir.
well.
Okay, others? Okay, if there is no other questions or comments, we can wind up here. Once again, thank you, Sourish, for today's session.
No, it's been my pleasure.
Okay, dear participants, let us wind up here. Thank you.
Okay.